she doesn't here. Maybe she can write. She can try to write so that we can know.
Exactly.
Okay, but we can't hear him.
But we cannot hear you. You are not talking. So are you ready to present about linear regression? We go first with the logistic regression. Yeah, I think maybe Abla?
I think she's trying to write. Let us just wait to see what she will write.
Okay. Okay, sure.
Okay.
So, Mustafa, I think your time is yours. Just present about logistic regression, which is relevant, the more relevant for this week challenge, because I know in the challenge they are asking somewhere to actually run logistic regression, yes, and decision tree and things. So I wanted to give some tutorial about that one. So, Mustafa, time is yours. Yeah.
Okay, John. Let me just share my screen. Can you see my screen?
Yeah, we can see your screen. Yeah.
All right. So, guys, in this tutorial, we're gonna talk about logistic regression. So, which is a very important topic, especially when it comes to deal with binary outcome, like outcome with zero or one, yes or no. Like for example, the doctor is testing some patients if they have a particular disease. Now the question is like, if the patient has the disease, it's yes or one, and if the patient doesn't have the disease, it's zero or no. So this is the kind of like data that we mostly use logistic regression. And what it does, logistic regression is like it tries to like you have a binary outcome and with some explanatory variables, with some other variables. So what it tries is, based on those variables, it tries to predict the probability of the binary outcome. Let's say, okay, there is a patient. We want to know if the patient has HIV or not, but he's not willing like to do the test. For example, he's not willing like to provide blood. Okay, but we know other informations about the patient, like we know the sex, the age, the area where he lives. We also know, maybe we can ask him if he's using condoms or not, something like that. Okay, based on those informations, we can try to predict the probability of that person having HIV or not. Okay, and it generates a probability which is like between 0 and 1. And we can fix a threshold. If the probability is greater than or equal to the threshold that we set up, we can conclude that, okay, this person, even if he does not do the test, but based on the information that we have from him, he has the disease, the HIV. Or if the probability is less than the threshold, we just conclude that even if we did not do the test for that person, but we can assume that the person doesn't have the HIV based on those information that he has provided. So this is like basically how we use logistic regression. Okay, so let's start. As you can see here, I will deal with like the Titanic data. Here I have imported some couple of libraries. Okay, the Titanic data is like, there is a column called survived. Okay, we want to know if like the person has survived or not, but based on some information. Okay, for example, we can, based on the sex variable, to see if like the person survived or not, or to try to know if the the number of females who survived maybe is higher than the number of male who survived. And we can do this by like considering some other variables like sex, age, or something like that, and then to predict the probability of a person being survived from this accident. So this is the Titanic data, and here I'm trying just to have a look at our data. This is the first 5 rows starting from 0. All right. Okay. Now, before we start, like I have maybe convert some variables. You know, for example, the variable cabin, I have like I make it to be a string. Like I have make it to be a string, and then for example, here I've created a new variables, for example, new cabin, and then I replace this variable with, for example, the new cabin. And here, as we have some maybe missing values, I'm trying to input those missing values with respect to the median age. All right, that's what I have done here. So now instead of age, now I have new age. Now this new age contains now, it doesn't have now missing values because I have removed, no, or I have replaced those missing values by the median age. I could have maybe like just remove all missing values, but it depends. Sometimes if there are many missing values, removing them might negatively impact or affect your analysis. So in this case, we prefer to input the missing values with the age median. Now that we are ready to use a logistic regression model to predict survival, we know that in scikit-learn library, we have like a logistic regression function in linear model subfolder. So let's make a logistic regression model that only uses the sex variable as predictor for now. As I said, we might consider many variables, and based on those variables to try to predict the probability of survival, if the person has survived or not. But firstly, we said, okay, let's first concentrate on the sex predictor. For example, based on the sex, let's predict if the person survived or not. If the number of male who survived is higher or less than the number of female who survived. Here I have just considered only one predictor. Okay, and from scikit-learn, I have imported linear model, these libraries, and as you can see here, as the sex, I'm trying to encode the sex because the way the sex variable is given here, you can see it is male, female, male, female. I only have 2 outcomes. So I want to make those outcomes to be 0 and 1. For example, male, if the person is a male, the gender is male, it's 1. And if it's female, it's 0, something like that. Because if I leave it like the way it is, it won't work. My logistic regression will not consider this. But I have to encode this, knowing that maybe 1 represent male and 0 represent female. That's what I'm trying to do here. And now I have initialized my linear regression model, my logistic regression model. And here I have an empty model. It doesn't have yet any argument inside. And now what I'm trying to do, now I have to train my model. Okay, let's train the model by considering like my X is the sex variable. Like I use the new version, which is the encoded sex that has like only 0 and 1, and my response variable is Y, which is the survived variables. Okay, so when I feed this model, I can try to check the model intercept. For example, this is the value of the model intercept, and this is the coefficient, and this is the coefficient of the model. For example, we can write this model we can say that like the impact of like sex on the survived variable is this number. Okay, here we only use sex as a predictor. Now let's make a prediction. we have trained our model. Okay, we want now to use our model. For example, anytime we have like a new data, for example, you just give me a data and I will tell you the probability of that person being survived or not. Okay, I use this function log model dot predict proba. This will predict the probability, right? And I have to specify the sex. Like based on the sex, what does it mean? It means that based on this sex variable, what is the probability of a person being survived or not? All right. So I converted this to be like a data frame. I put this into columns, for example, and I print my result in the form of like, for example, a table with respect to the sex and the number of the number of people, the number of female who survived or who did not survive, and the number of male who survived, and the number of female who male who did not survive. Here the probability is here, for example, let's say if the sex, like the sex is here, female and male, and here you realize that the probability here is small, that means the person survived, right? And here the probability is higher, that means the person survived. And we have a total like this. We have, for example, 314 female who survived, and we have 577 people, male who survived. So this is my prediction. And also don't forget, you can always try to check, you can always check the performance of your model by using this log model.score. Okay, that means like how well your model performs. Okay, you put as arguments the predictor variables and the response variables, and it gives like this. This is the like 0.78, which is not bad. Maybe it depends on like what we want, and we can still improve it by maybe adding more predictor variables, because here we only consider the sex variable as predictor. Okay, and we have this accuracy, the score, and let's say maybe we want to improve this. In this case, we can try to maybe add more variables. And the table shows that the model predicted a survival chance of roughly like 95% for male, for example, and 73% for female. That means in that accident, females had more chance to survive than male. And I think from the statistics, the real statistics, it was like that. We had more females who survived than males. So this is the use of like logistic regression. It's not really complicated. So if you have your binary outcome and you have some other variables called predictors variables, and based on those variables, you can try to predict the probability of like the binary outcome. And then based on the probability, maybe you have a threshold. If the probability is higher than this, then you can like assume this. And if the probability is less than the threshold, you can just assume this. So here, if we use this simple model to predict survival, we would end up predicting that all women survived and that all men died. That is what it's trying to say. Okay. And in this case, we said, okay, let's try to make our model more complicated. Let's try to maybe add more variables, more predictors variables. Okay. And here we add this, we had the class and the cabin, for example, as predictor variables, not only sex variables. And then we like just call this set of predictors variables trend features, and we make them to be a data frame. For example, we have encoded the class variables, we have encoded the cabin variables, and they are here. Also, remember we already encoded like the sex variables also, and we have age. So that means this time, apart from the sex variables we considered for the previous one, we have added 3 more variables: the class, the cabin, and the age, right? Okay, now here let's initialize our model, and then let's train our model. Now the predictor variable will be all these variables. X, my X will be like a matrix with this variable, a data with these variables, which is here. X is equal to 10 underscore features, right? And then I have to specify my response variables, which is the survive data variable, and this one doesn't change, right? And then here I've just checked the intercept of my model and the coefficients of my model. As now I have 4 predictors variables, so of course the coefficients will be 4. For example, this coefficient will be 4. For example, the class, this coefficient will be for cabin, and this one will be for sex, and this one will be for age. Okay, now this time let's try to make some prediction using this model, and then compare the prediction to the actual values. Okay, we use this function to predict by specifying the predictors variables that we use, and then here we just print out as a cross table the variables. Like what is has predicted is that, for example, for male, for female, we have, for example, 400 for this is, I think this is for male, yeah, because the male was one, I think. For male, we have 458 who died, and we have 89 who survived. Okay, for female, we have 91 who died and 253 who survived. And you can see here still, the number of female who survived is higher than the number of male who survived. Okay, so here I try to maybe print out the score, like how well my model performed, right? I have just to specify my predictors variables and my response variables, and this is like the score. For example, let's say around 0.8%, let's say that, of performance, even if it's not like that much bigger than the previous one, but at least we have better performance. And you keep doing this, you can keep doing this, playing around the variables, adding some variables, taking back some variables, do some like kind of just try to play around these variables, and maybe you can have a better model, model. Maybe you can try to include more variables and try to remove some variables. And I think in Python there is an automated process that will help you to select these variables at once. Like you initialize your model and you run that code, it's like selects your models and gives you like the best one. For example, let's say I think in support vector machine I use like what is called green shirt. Green shirt, you have just to specify like those arguments that you want to use, and then it just gives you the best model among those models. You will not be like here wasting time trying one by one, but I think there is a way to like automate this, and you just have the best model, and based on that model you can have a good prediction on what you want to predict. So this is the end of my presentation. It was just like an introduction about logistic regression. Thank you very much for your attention. If you have questions, I'll be very happy to answer. Thank you very much.
Thank you very much, Mustafa. So some questions are like in the chatting box. Maybe you can see and try to answer what.
Oh, okay. Okay, is trying to ask if a cross table is like a confusion matrix. Yes, let's say yes. Yes, let's say yes, because in the confusion matrix you have like some like the results of your prediction, and then maybe the model did not. The model did not predict very well some like maybe data, and he predicted very well some data. So let's say the cross table of this, it's like the confusion matrix. Let's say yes. Okay, the next question was, what is the difference between label encoder and get dummies in pandas? All right, the difference is like dummies in pandas means like for example, you want just to have maybe 0 and 1, for example. Okay, you want to have 0 and 1. Okay, encoder will help you. Here we only have, for example, 0 and 1 as well, two outcomes, male and female. But let's say, let me give you an example of salary. For example, we have medium salary, poor salary, higher salary. For example, you have three values there. In this case, if you use encoder, it will automatically assign, for example, higher salary to be 1, medium salary to be 2, and like small salaries to be 3, for example. But dummies, I think dummies can just convert it to either 0 and 1, like just two values, right?
Yes, the dummy will take all the modality, all the possibility of a variable, so a categorical variable. And
Yeah.
so like if I take the variable color, for example, then you will have red, then you will have a green and blue and black. So for each of them, it will transform it into a new variable, a new binary variable. Yeah, so it's will take the red and they say, yeah, if it's red, then let's put 1. If it's not red, let's put 0. Yeah, so all the possibility actually in a variable will just be transformed in new variables and encoded with 0 1 0 1 0 1 depending on the value.
Okay. So the next question is, I think, about the coefficients of sex. The coefficients of sex, I think, is here. Okay, this is the coefficients of sex. This is to tell you that like like how much the sex variables explain the variable
Yeah, so
I,
like,
like the sex variables
yeah, so
explain
normally,
my outcome.
yeah, yes, yes.
Okay, Jean,
So
if
it's
you
like
want to add something.
in the logistic regression, it's like a process. This is why it's a little bit different from the linear regression. Like it will just set up like a default value. So if you take the sex, there is two possibility. So the first is male, and the second is yes, and the second is female. So it take automatically one of them as default, and
Yeah.
it compare the effect of the second one compared to the first one on the target variable. So if you get a coefficient of like about 1.0,
Yeah.
so that would mean that compared to the
Can you go to
default,
where the coefficient is so that we can see it
yeah.
in the screen? So that we can see how to
So
explain.
okay, so that compared to the default value. So let's say the default value, for example, is male, and the considered one in the algorithm is female. So like, and then the coefficient value is 2.5. So compared to the let's yeah 2.5. So compared to the default value, which is male, females have 2.5% like more chance to survive than men. So like it's always compared to like default value. So like this is how you interpret the coefficient, but you can also Google to have some good resources about just type on Google how to interpret logistic regression coefficients, and then you will get it. Yeah. Bam, bam, bam.
All right.
Yes.
So,
So,
but anyway,
so
I think we are running out of time. So,
yeah, yeah.
Abla has to
Okay.
present. If
Oh,
maybe you
Abla,
have
I don't
question, we
know if.
can still continue on the Slack channels.
Yeah, yeah. So I don't know if Abla has something to present. If not, I don't. I think logistic regression is actually the one they will probably need in this week challenge. So even if Abla don't want to present today, this is not something I think we can manage so that we'll make a presentation about linear regression later. So I don't know. It depends on Abla. If you want to present now, yeah, Abla, we can hear you. Yes, hello. Do you have? I think it's like you have some connection issue because we cannot hear you. Maybe you can take the time to solve your issue, and then later we will just report the linear regression.
All
Yeah.
right.
Yes, you are
Hello.
here. But can you talk? Can you
But
talk?
the problem
We
is we
cannot
can't
hear you.
hear her. I don't know.
If you are here, just come like talk and go on.
Right. We can just try to do John
Yeah.
as you said.
Yeah. Okay.
Maybe
Yeah.
we,
So
we,
what
we,
I
we don't
will
want to
do
keep
is to
you.
share.
Yeah.
I am talking, but it looks like okay. So it's like there is some issue.
Yeah.
There is some issue because we are not hearing you at all. You are talking, but we are not hearing you at all. But you able to hear from us? Maybe you can connect. You can disconnect and connect again. Can you try that?
All
Yeah.
right. So let us wait a minute.
Yes. So what I will do is to share. I want to share some resources. I think this one is actually so good about logistic regression, how to interpret the coefficients. Yes, because this is very important. After yeah, when you finish your analysis and you are able to get your model coefficients, you should be able to interpret, yeah, so that you can actually appreciate the effect of some variables, some explanatory variables on your target variables. Yeah. So that's why it's important to know how to interpret the coefficients. Yeah. So in your weekly challenges, like so you will have to determine the target variables yourself, and you will have to perform logistic regression, and so you will have to. So it's already asked to split your data in training set and testing set and validation set. Yeah. So like. Mhm. Why not? Why are we running a linear regression? Are you running a linear regression for this for the challenge? I hope it's a logistic regression, or is it a linear regression? I didn't. Let me check it. Copy of. Where is the challenge? Mhm. I can see logistic regression, decision tree, and history boosts in the challenge. Yes, I can see logistic regression. Is it linear on your side? I think I can see logistic regression in the challenge. Like logistic regression, decision tree, and history boost. I think so. Yes, it is logistic regression. So you will choose you will determine your target variables. You already have a question which asks to sample to split in training set, testing and validation, and from there, I think Mustafa, you will share the tutorial in the today folder so that they can have access to the code. If they want, they can use and update it. Yeah. And so apart from that, you will be like, yes, so you will have to appreciate your model. Yeah, you will have to define a loss function. Yes, so I think, let me see if okay, but so about the loss function, so and you will define the appropriate loss function yourself. So you will Google about that. And oh yeah, the link for this week, let me see the link. Where is the week folder? Let me see and share it with you. The Google Drive, I'm not get okay. It's like here. Okay, wait for. Okay. Yes. Yes. And yes. Yeah. So this is the link for the week 4. Yeah. Did the meeting just start? No, the meeting didn't start now. I think you will have the recorded video for that. We are ending the meeting right now. Do you test for collinearity among the feature or logistic? Oh yes, normally we should test for collinearity. Yes, it's always good to check about collinearity. Yeah, even if you are not, because most of time when you do collinearity, you will just like remove the correlated variables. Yes, you will remove the correlated variables from your things, from your features. But I think in the challenge, don't remove. It's good you can check for collinearity to just I think you also don't have a lot of many feature, but it's good you test for collinearity and report about that. Even if you are not removing anything or you are not threatening the collinearity, it's always good to, yeah, it's always good to check about collinearity. Yes. And okay. You remove all correlated variable, just remove. Yeah, so you can check and just like report about that. What is our trigger for the yes, so you are asking a question, so I will not answer this question because you have to determine it by yourself. You can ask your classmates, but me, I'm not responding. Yeah. Okay, so thanks so much. I think Abla is not here. she cannot be. It's like some connection issue from her side. Okay, so I think she will give the talk about linear regression later. Yeah. So, good day and good. I think you will have now time to continue working on your challenge. So on this, I am letting you. I am ending the tutorial, and I am thanking Mustafa and thank everyone for attendance. And